Hello? Alright, let me begin by specifying what artificial intelligence is, and like what we're actually debating. The artificial intelligence we're debating is like the general type. So will robots and machines ever have general intelligence? The ability to have open-ended goals and to generalize from one domain to another, like humans do. To do so, they would require feelings, self-awareness, consciousness. So let me begin by stating two assumptions of AI researchers. The first is that the brain is analogous to computer hardware, and that the mind is analogous to computer software. The second assumption is that our knowledge can be manipulated according to some formal rules. So basically, thinking is just this complex process of data processing, and our knowledge and thinking is based on logic at an atomic scale. There are several problems with these assumptions. The first is that symbol representation and manipulation, which is what computers do nowadays, just isn't enough to qualify a machine as having general intelligence. More on this later with the Chinese room analogy. But essentially, in the real world, problem solving requires creativity and adaptability. So we don't compute and deduce our problems like computers have to. What we do is, actually scientists say that know that our knowledge is stored in our brain intuitively, not symbolically. So we're nothing like computers, and our knowledge is not like in a computer program. We don't. So we can do something based purely on our feelings and our beliefs. For example, believe in God. So problem solving and like searching for a solution in the real world is actually just a continuous process of setting priorities, and priorities are usually based on our feelings. So no programming or setting of rules will ever be able to encompass who we are. Now, if we focus on the brain, which we must understand and simulate to create AGI, we can realize what we're really up against. Neuroscientists doubt whether we will ever have the ability to reverse engineer a brain. Why is that? Well, there are thousands of neurons in your brain, and each neuron is as complicated as the city of San Diego, as neurobiologist David Eagleman put it. In addition, there are hundreds of thousands of trillions of connections between these, and these are very complicated between the neurons. In addition, the brain is not a static entity, it is very dynamic, and the interactions in your head are actually changing over time, every second. So as the scientists try mapping out the brain and determining whether it is modular, what are the modules of the brain, and how many there are, they might have to deal with the sad fact that it's not for us to understand, let alone engineer.
So I'm going to continue on the Chinese room. Basically what the Chinese room is, just picture a big room and there are just two doors. One door is an input and the other door is an output. What this Chinese room analogy symbolizes is what happens in the brain of a computer. So from the input you get a card, a symbolic card, a symbol, and you have a person that speaks only French in there. In this card, it's written in Chinese. And what this French guy has, it's basically a big book that answers all the questions to the universe. So he takes the card and he looks at the character. He doesn't know what it is, but he has a big book that tells him what it is. And then using that book, he gives an output, basically an answer. So there's the whole process going on in the computer. Therefore, what this suggests, and what John Searle suggested, that this whole process doesn't make the person, the French guy in it, understand this Chinese character, therefore understand Chinese. What it does is just manipulate, and that's just not intelligent. My second point is going to be about common sense. Hubert Dreyfus says that common sense, to have intelligence you need common sense, but to have common sense you need to know about. What does he mean by know about? He means common day-to-day experiences and interactions, such as riding a bike. Like I'm sure all of you over here, you're all ridden bikes and you've all fallen and you know how to ride a bike. But can anyone tell me over here who has learned how to ride a bike from a book? Well, that's what computers do. They take a book, they read it, and they try to understand. But that's not common sense. And my third point is going to be about emotions. Master engineers or software engineers can mimic emotions for computers to see emotions in a guy and tear up or not. But in reality, do they actually feel emotions? No, because they're just made of silicone chip-based elements, and these silicone chip-based elements don't have feelings.
So hello everyone, welcome to our debate and stuff. We're arguing about artificial intelligence being impossible, but we're against that idea. So we're for artificial intelligence, right? So you guys have all heard of the Terminator movies, or like robots taking over the world and everything, and they're gonna take over humans and all that. That is developed artificial intelligence. That is like extremely advanced artificial intelligence. That is science fiction for now, but arguments are that it will be possible in the future. It doesn't matter how long it will take, but it is still possible. So what is artificial general intelligence, what they defined it? Well, we're going to add self-improvement to being able to adapt to things and just improve your general situation and not just take instructions and output them like the Chinese book thing. There's also self-awareness, so emotions in robots, we're going to discuss that as well, and we have some arguments for that. I'm going to pass it on to Etienne right now, and he's going to tell you some stuff.
Good evening. So, the main argument against robots is that they're programmed to do a specific task, and if you change any environmental factor, if you change any input, they will not be able to do that task anymore. And that was true until very recently. Nowadays, people at the Institute of Technology of Tokyo have devised a robot that can actually analyze its environment and conduct a task that it's not generally programmed for. It can identify a glass of water, identify water, and pour the water in the glass, realize that it has only two hands and has to put down the empty glass, pick up an ice cube and put it in the glass. Now this seems really easy for us, but from something that usually doesn't even know it exists, it's really hard for something to realize that they have two hands and they have to put down an object in order to pick another one. So this is one of the first steps to self-learning and general data processing, which means that it's not a specific input, but it's a general input that results into a specific task. And we will tell further later that even basic emotions can now be seen in robots. I'll pass on to my colleague.
So let's keep this simple, guys. Imagine 400 years ago. You go up to anyone on the street, you ask them 8 times 7, they answer you 56. It's very, very, very nice and simple, right? Blaise Pascal comes out with a calculator. Big mechanical device, lots of turning gears, very complicated. Everybody hates it. They fear it, they don't understand it, and most importantly, they don't believe in it. They don't actually understand that it's giving them the right answer, more reliably than they could, right? All of a sudden, skip ahead 350 years, let's go back to our parents' time, right? You're starting in high school. You all of a sudden have this beautiful device called the calculator. It's this big. Again, everybody doesn't understand it, but after a year, after 3 years, you finish high school, you don't know what 8 plus 7 is. All of a sudden, you can't do basic computation because we're relying on the calculator. Now, I'm not telling you that a calculator can think. It's not artificial intelligence. What I'm telling you is that you don't understand technology. It's just that simple. We're looking around, we're visualizing a basic computer. I have a Mac at home. I'm not telling you my Mac is intelligent, but I'm telling you I have no idea how it works, right? We have stuff, and when we imagine artificial intelligence, we're imagining basic computers. That's not what it is. There are robots out there doing much, much, much more complicated tasks than we understand. Look at search engines, look at Google, look at Wolfram Alpha, who is thinking a lot more than you can, I believe. I'd be hard-pressed to ask any of you how to solve a very, very complex integral. However, Wolfram figures it out very simply, right? Again, I'm not telling you that Wolfram thinks. I'm telling you that you don't know what the future will bring. We don't know where technology is headed. We don't know what it's going to give us. But I can tell you that you can't prove it won't be intelligent.
Okay, 30 seconds left. So people are saying it's not possible. It's too complicated to understand neurons and listen to this. Exponential growth of knowledge. It will happen. Eventually, we will find out. If it's complex, we'll figure it out. Look back 1,000 years. Compare life that back then to now, and you'll be like, whoa, it's possible.
4 minutes break.